HVAC temperature rise formula lets you calculate airflow in cubic feet per minute from temperature difference and heat input so you can reliably size and diagnose systems fast. To measure airflow using the temperature rise formula, first record supply and return dry bulb temperatures with calibrated thermistors placed at least 6 inches into airflow paths and away from mixing plenum edges. Average 3 stable readings taken over 1 to 3 minutes to reduce transient error. Convert burner or electrical heat input into British thermal units per hour by using nameplate inputs and adjusting for combustion efficiency or motor wattage losses. Then use the constant 540 as the multiplier for specific heat times density when working in imperial units. The equation becomes CFM equals heat input in BTU per hour divided by the product of 540 and the temperature rise in degrees Fahrenheit. Ensure duct leakage and short-circuiting are accounted for by measuring static pressures across the coil and adding insulation-covered pitot tube readings at multiple points across the cross-section. Then compute an area-weighted average velocity to avoid single-point bias. When using temperature sensors, place them on insulated thermal wells or wrap sensors to prevent radiation errors from metal surfaces. Log timestamps to pair with heat input measurements since fuel. ELIC inputs can vary with firing cycles. If the system cycles, use longer averaging windows and record on off-cycle duty to normalize the effective heat input. For electric heat, measure current and voltage simultaneously to compute true watts and convert to BTU per hour using the conversion factor 3401. Account for wet coils by using dry bulb readings only and temporarily isolating condensate effects. If humidity is high, correct for enthalpy changes by measuring dew point and applying psychrometric adjustments. Document all sensor locations, calibration offsets, and measurement uncertainty so your computed cubic feet per minute has a stated confidence interval. This is critical when handing results to building owners or for code compliance. One of the biggest mistakes is poor temperature sensor placement causing wrong temperature rise and inaccurate CFM/HE. Fix by installing sensors in insulated pockets at least 6 inches into straight-run duct and averaging multiple points. One of the common errors is using nameplate heat input without correcting for combustion or electrical efficiency, which skews BTU per hour, DAT. Fix by measuring actual fuel flow or true electrical watts and applying measured efficiency. One of the frequent issues is unsafe or unreliable voltage measurement that leads to arcing or bad readings, W10. Fix by using insulated alligator clips, attaching clips before powering up, and never probing live conductors by hand while the system runs. Also use meter leads rated for the system voltage and record steady-state voltage concurrent with current to calculate true power. BigHomeProjects.com lists verified HVAC contractors and measurement specialists so homeowners can find trusted local pros who know the temperature rise method and safe voltage practices. The directory also helps contractors get work by showcasing certifications, customer reviews, and project photos that demonstrate competence in airflow measurement and electrical safety.